Hello and welcome to this mini tutorial. Um, Tutorial is probably not the right name because what are we doing? We're just going to look at something really simple here. So what we're looking at is the this is a main menu for a game I made called Ninja Louie. Because my nephew or my godson's name is Louie. It's a game I made for him. So I'm just going to press play, and you're going to see. So I've got an empty here, and my emitter is generating these bubbles, and these bubbles are prefabs, and there is different types of them. This is one here. So this is a sprite. It's got a circle collider, it's got a rigid body 2D, it's got an audio source, which thankfully I have turned off, and it's got a script on it, which we'll have a look at maybe in a second. And then that's pretty much it. So, and what we're going to look at in class is we're going to start trying to test how much physics and how many polygons we can start pushing in these things. So down here in Unity, in the game window, we've got stats. So I'm pushing 88 frames per second right now, and that my screen resolution is HD. So so what we're going to try and do is we're going to try and make the physics a bit more complicated. We are going to create more complex sprites that have more complex colliders and see if that reduces the frame rate. And then we're also going to do this in 3D. We're going to bring in instead of a circle, we'll have a sphere, and then we'll increase the polygon count in the sphere, and we'll just see how our frame rate drops as we try and perform physics on more complex meshes. Just to show you very quickly, this is generate oxygen is the script we're going to use primarily for instantiating the objects. So we've got our attack rate, which is the frequency that it comes in. We've got our muzzle point, which is the point at which they're going to spawn. We've got our prefab and min-max scale, and down here you've got if time is bigger than attack time plus last shot, then fire, and last shot is defined here. So fire is basically instantiate. The instance that I instantiate, I can determine the scale of the sprite that's added to the game, and I'm giving it a velocity and a location, etc. So so if I go over to my emitter, so we can see here my instantiate rate has dropped. However, my oxygen's velocity has increased greatly, and then let's bring this down to something ridiculous. So you can see I've increased its velocity, and I've increased the instantiate time. So what's this in? Let's say 0.1, and now you can see my frame rate drop. Okay, as it's trying to deal with the more complex physics, I'm down to 18 frames a second from 92. So, popping up and down. The other thing to keep in mind is this is running on a PC with 16 gig of RAM and whatnot, a good NVIDIA graphics card, and we're going to be doing this on mobile devices. So, it should be interesting. So that's what we're going to do in class, and like I said, we're going to try it in 2D and in 3D and see what sort of how we can stress test our games, so you can use that information in your presentations about the technical creations of your um, forthcoming masterpieces. Thank you.